Hi everyone, this is Jelly. Today we're going to talk about the scanning system of a laser cleaner. As we know that laser cleaning machine made of laser source, chiller, sometimes chiller, if air cooling, low chiller, and control board, and the cleaning gun. So in the last video, we've already talked about many parameters of a laser source. The frequency, the down power power reduction frequency, and pulse type, pulse width, all these parameters. So in this video, we're going to focus on the optics movement, which is the laser cleaning gun. So for the laser cleaning gun, we can think about the gun as we call it laser cleaning gun. Sometimes we call it laser cleaning head, but many people would like to call it laser cleaning gun. So if you think it's a gun, the laser source is a bullet, which you need the bullet for a gun. So the frequency means the number of bullets you have in every minute to give to the gun. And the way of the bullet moving is the scanning pattern. So there are many parameters also involved in that, the speed of the optics and the way of moving the laser. So when you're shooting the laser in a linear way, when you choose the linear pattern of the laser cleaning gun, actually the laser is not going, the bullet is one by one. So when you're cleaning the linear pattern, you set the weight, for example, 120 millimeter. Actually, is the laser dots, the bullet, in high speed moving, very high speed, because they are moving by the goblet scanner. So when you set the laser frequency to 1 kilohertz, and when you look this line with the microscope in 235 times bigger, you enlarge this line, and you will see they're made of dots, a lot of dots, which means the laser beam, the spot moving one by one, just in a very high speed. By your eyes, you cannot see that, so it becomes a line, but actually it's moving. It's a high speed moving of the laser. So if we know this concept, in your laser cleaning machine, you will see many patterns. Some patterns like this, they shows like this, some like this, some like this, all kinds, some like flowers. There are many fancy ways, but no matter which pattern it is every single laser, they move one by one, here, here, here. So the shape is made of the laser fast moving in this way. So why we design so many patterns? Why you need? And which kind of pattern is the best? How to choose them? So as we know that when we are doing a cleaning, maybe clean the rust or paint or furniture, what kind of effects you want? You want a very equal cleaning, which means that you clean everywhere in the same laser, same power, same speed. You get very equal quality. No overburning or not cleaning. So when we choose the pattern, no matter which one you choose, you want to get the equal cleaning effects. Because it's a handheld laser cleaning gun, so during the operation, you might vibrate in your hand. Maybe the surface of the cleaning, the object is not flat, and the focus is moving. And the speed, when you're moving the laser cleaning gun, maybe fast or slower, you're not in the actual very equal speed. This will also affect the cleaning effects. And also, when you choose the patterns, when they're moving, there are spaces. Like this flower, probably you got overlapping here, and you have the space here. So there are many factors affecting the cleaning effects. So let's take a look the patterns of our machine. There are more than 10 patterns, and you can choose for different objects cleaning. And you can try which one is the best suitable for the object. As we know that there are some patterns they only suitable for automation cleaning because the focus is always fixed, but some patterns are suitable for handheld, like the random pattern, which we use very often. This pattern is quite suitable for handheld because your focus always fluctuating. When you're testing different machines, because different manufacturers, they gave different patterns, they design different patterns. And some of the patterns that look similar. They look similar in the shapes. But when you test the real cleaning effects, I mean, we made this experiment. We put two different machines and we choose the similar patterns and we set the laser, all the other parameters in same numbers. But you get very, very different cleaning effects, or even the speed and the quality and ability of the cleaning. So the result is that even you choose the similar or the same pattern, but you probably don't get the same cleaning effects. Why? So why we choose similar patterns and the same laser and all the other parameters we set the same power and the same speed, same wavelength, well, we get very different cleaning effects. Why? Because there are some difference that we will not see from our eyes, like these patterns. Even we know that it's every dot moving. And the laser, if the laser has slightly different, it's all 300 pulse, but probably you have different beam quality and you get the different power density. Every bullet, every spot are different. So you will get very different cleaning effects, even you use the same pattern. And if the same laser, they have the same density of flat spot, even you use, like the shapes, if they look similar but they're not the same, very slightly difference, like where your laser, your beam start, like the circular type, where you start, where you ending. I mean, these are not, because it's high speed, and all shapes are moving in few nanoseconds, and it's not easy to be catched by your eyes, but they create the actual difference in the cleaning on the surface of your material. So we are trying to explain that there are many factors. When we design and build the machine, we try to optimize and to get the best performance. But still, the effects quite varied from the actual cleaning process. So we welcome you to involve in this discussion what you discovered. I noticed that many people send me emails. They have many types of machines, different brands or different power range. And we welcome you to feedback us what you found in different patterns and different machine, what you get, your opinions, and maybe we can improve better in the future. Our hologram designer will make better patterns according to your experience. Thank you.